Good morning everyone. So in the previous slide we have been discussed about what do you mean by construction, what are the importance of construction planning and what are the stages in construction, and also we have discussed what are the stages in construction planning, what do you mean by bar charts, what are the limitations of bar charts. Next we have also discussed about CPM and PERT, what are its advantages and what are its features of CPM. So today we'll be discussing about construction scheduling. Construction scheduling or simply scheduling in construction means the process of fitting the final work plan into a time scale indicating the start and completion time of each and every construction activity. So there are two types. First is Gantt chart scheduling and next we'll be reading about network analysis and scheduling. So in the Gantt chart scheduling, Gantt chart is a chart that is used for scheduling of construction activities. The Gantt chart consists of the construction activity on the y-axis and the time duration on the x-axis. It is also called as bar charts. The activities are shown separately by bars, where the length of the bar shows the duration that the particular construction activity takes to complete. The progress of the construction activity is shown by shading the bar with color or any type of a materials. Okay, so we can say that Gantt chart scheduling, it is a chart which is used for scheduling all the construction activities, and it consists the construction activity on the y-axis and the time duration as the x-axis. Okay, so next we'll be reading about network analysis and scheduling. The network analysis consists of methods to assess the various construction activities, their interdependencies with each other, and find out the activities that need most attention during the progress of a construction project. So next we'll be reading about what are the features of network planning. So this comes in the semester exam 2-mark questions. You can note it down. The whole project is expressed in graphical form, showing the events, activities and the interdependencies. The network shows the critical activities and events which need special attention during the progress of the project. The network can be used for the time cost optimization. The resources can be allocated or diverted from one activity to other for optimizing it. Okay. So next we'll be discussing about what are the terms which are associated with the network analysis. First is activity. Progress of a specific task or construction activity which has a definite beginning or end is called an activity. Next is event. The beginning or end of an activity is called an event. We will be showing in the solving all the problems. So we can discuss. You can know what is activity, what is event, network, what is the dummy role. You can all know. Okay. So next we'll be reading about network. Network is the interconnection of the multiple events and activities, showing their interdependency among them. Dummy represents a dummy activity which does not consume any time or resources but shows the importance of completion of an activity before start or another. Next, also we can say the dummy serves the two purposes. First is logical purpose, next one is grammatical purpose. Next we'll be reading about what are the terminology for critical path method. First is activity duration. The time duration that an activity takes to complete, that is known as activity duration. We can denote it as T subscript of INJ. You can see here it has been denoted as TIJ. Next, that is earliest start time. Earliest start time at which the activity can start. Okay, this is known as EST. We can say it as earliest starting time or earliest start time. Next is earliest finish time. Earliest time at which an activity can finish, that is called as EFT, earliest finishing time. And this is one of the formula. You can see here EFT equals to EST plus activity duration, that is TIJ. Okay. So this is the formula of EFT. Next we'll be reading about latest start time. Latest start time at which an activity can start without delaying the project. without delaying the project, that is known as LST. Latest finish time, latest time at which an activity can finish without delaying the project, that is called as LFT. So LFT equals to LST plus Tij. It is the formula of latest finish time. Okay. So these are the activity, the terminology for the critical path method. You can see here, this is one of the problem you can see here. Okay, activity duration, EST, EFT, LST. This is the formula for all this. So this is the question. For the following data, draw the network, find the EST, EFT, LST, LFT, and find the critical path and project completion method. So this is the activity. Next, this is the duration time. You can see here we have drawn the activity here. Activity 1 to 2, duration is 20 units, 1 to 20 units. Next, you can see here activity 1 to 3, duration is 25, 1 to 3, duration is 25, 2 to 3, duration is 10, 2 to 3, duration is 10. Next, you can see 2 to 4, duration is 12, 2 to 4, duration is 12. Okay. 3 to 4, 6. You can see 3 to 4 denotation here is 6, and last one is, that is, we can say it is denoted as 4 to 5, 10. Okay. Here you can say it is 4 to 5 as a 10. Okay. So these are all the questions you can see here. And we will be solving this by the formula, that is EST, EFT, LST, LFT, and this is the FT, FF and FID. This is the total float, this is the free float, and this is the independent float. Okay, we'll be reading here, and you can see this is the 00 and this is 20, 20, 36. These are all the EFT and the LFT. Okay, so you can see here, this you can see, while you are adding this, we will get the value this is. So first starting point, that is here 0. Then after that 0 plus 20, here 20 is written. 20 plus 12, you can see here it is written. Next you can see here 20 plus 10, here you can see 30, and here 30 plus 6, here it is written as 36. Okay, so we can also denote one thing here. You can see here 2 to 4 and 3 to 4. 3 to 4 it makes here 30, and 2 to 4 it makes there 32. Okay, so we will take the highest point, that is, we'll take the 36 as a highest point. Okay, here, then 36 plus 10 as a 46. Okay, so this is the EFT, and this is, we'll be subtracting it. This is the LFT. 46 here written, 46 minus 10, this is 36. 36 minus 12, you can see here 20. Here it comes also from 3 to 2. Here the one activity arises. You can see here 40, 36 minus 6, you can see here 30, 30 minus 10, 20. So when the small number arises, we can take it as a small denote, we can take it as. Okay, so you can see here activity 1 to 2 up to 4 to 5 it has been written. Next, here you can say duration in days. Next, that is EST. As previously we have known, the EST means what? The earliest time at which the activity can start. You can see here, it is the earliest time at which the activity can start. This is the 1 to 2, this is 0, 1 to 3, this is 0. Okay. Next, how to find the EFT? EFT formula is what? EST plus the duration of the activity. So we can say that EST plus duration of the activity we have been find out here. Next is LST. LST formula, that is here the latest time at which the activity start without delaying the project. Okay, this is the activity start without delaying the project. Next is LFT. LFT formula is LFT equals to LST plus Tij. Okay, so LFT equals to LST plus Tij. After that, we will be finding out FT. FT means EST minus EFT, LST minus LFT. We have to find out this. Okay, So we have to find, so before subtracting we can say it as, we can see here LFT minus EFT minus LFT, EST minus LST, we can denote it as 0. Next we can see EFT minus LFT, 30 minus 25 is 5, or you can say LST minus EST as a 5. Okay, this is the FT, that is the total float. Next is free float. You can see here 0, 5, 0. While subtracting it, we can take it as a 0. Next you can see independent float. Here from FT minus free float, total float minus free float, we will be taking it as independent float. Okay, so we get it as 0, here 0. This is the all, while we will take it as FF, this is a free float, we take it as a 0 as a critical path. Okay, so this is the form, all the problems. This is one example of critical path method. You solve all the examples. Then if any doubt occurs, you can ask me. Thank you.